equals a, how accurate is the approximation L of a plus 0.1 approximately f of a plus 0.1. And so someone asked me to do one of these just to kind of walk you through the process, so that's what I'm going to do. In class, when we were talking about linear approximation, the formula we came up with is y equals f of c plus f prime of c times x minus c. Well, in order for this to apply to what the directions is saying, it's easier, instead of saying y could be replaced with L of x, because this is also just a linearization. So it means the same thing, they're synonymous. So all this is saying when it says find the linearization L of x is use this formula that we've been using. And in this particular case, instead of C, they've used A. But this is the same thing as C equals 0. So they're saying approximate by using the x value of 0. And then when we get our linearization, we're going to approximate what it would be. So we need an x value. And that's when you look up here where it says a plus 0.1. You take a, add it to 0.1, and 0 plus 0.1 is 0.1. So that gives us an idea of what to plug in where. And then I need to find the linearization. So I need f of c, which would be f of 0. I need f prime of c, so f prime of 0. F of 0 would be plugging 0 into our function. Natural log of 1 is 0. And then f prime of 0, where you have to remember the derivative of natural log, which is u prime over u. X plus 1 is your u, and the derivative of that is just 1. And then u would be x plus 1. And instead of x, we're plugging in 0. So get rid of the x, replace it with 0. That was just 1 over 1, which is just 1. So when I put it all together for the linearization, we're taking the linearization of 0. So it'd be f of c, which is 0, plus f prime of c, which we found to be 1, times x minus c, which was 0. And when you put it all together, it equals just x. So our linearization approximation, this would have been the linearization. And then when I reduced it down, it's equal to x. So formally, we would just call this the linearization. Now I need to compare the approximation to the actual. So the approximation would be what I get when I plug my x into linearization. So that would be 0.1. And then f of a plus 0.1 is what I get when I actually plug it into the function. So f of 0.1 would be natural log of 1.1, because it's x plus 1, and so 1 plus 0.1 is 1.1. Now that's something that, you can't really do in your head, so we need to do that in a calculator. And so put in my calculator, natural log of 1.1 is 0.0953, approximately 0.0953. And if you compare it to your linearization, it's pretty close. If I rounded this number up, I would get 0.1. And if you, want to have some kind of conclusion, you could say, let's see, 0.1 minus whatever you got when you found the actual function. So 0.1 minus our answer. There is a 0.005 or 0.004 difference between the linear approximation and the actual value. And so that would be the process for finding the linearization and then taking that approximation and comparing it to the actual function.